Yeah, so last time we ended with you wanting to talk extensively about solar energy and electric vehicles. But before we get into that, I just wanted to ask you a couple of things based on all the last interviews. If we talk about import substitution, right? Is there or has there ever been a conscious attempt by the research park to identify areas of import substitution? That is one. And the related question are some of your most successful projects import substitution related projects, or are they products that are totally unique to India and have been thought as such?
So, research park will not be very even competent on import substitution. Import substitution invariably implies opening up the system, looking at it, and just copying certain part or redesigning certain part. Invariably, the industry-academia interface and innovation and entrepreneurship implies completely thinking afresh. I'll give a specific example. And if you don't think afresh, you cannot get where people want to do. I probably talked about that once Wagul has challenged me that if you can make the ATM at 1 lakh rupees, I'll put it in every village.
So you've talked about it extensively.
And in that, the issue was, my first reaction from our side was, we didn't know what ATM was, we knew what functionality was, how to go about building it, what are the parts. So some of my colleagues all said, let's open up ATM and look at everything. And of course, Wagul said, well, I can arrange for that. And I said, no. If we look at it and figure out what they are doing, our thinking will get limited to that. And if our thinking is limited to that, we'll never be able to do the kind of cost reduction that Wagul is challenging us for. We may be able to do some reduction. From 8 lakhs, we may be able to get to 6 lakhs, 5 lakhs. Getting to 1 lakh means a totally fresh approach to the problem. Define what we are trying to do. Let us say, how will I do it? Do it as much as possible. Later on, open and see whether they have some area of strength which you have not captured. So, this is what innovation means. This is not import substitution. There are industries which will do import substitution, which is fine. In some sense, when I design a totally fresh motor, I am, of course, replacing the import. But it is strictly not import substitution.
If you take perhaps your two most highly valuated ventures, one is Atha and the other is Unifor. Right? Where do these two stand in technological comparison with the same functionality in other countries?
Okay, so Ather in particular, let's start with Ather. Ather is making a two-wheeler with Indian market. There is not as strong a two-wheeler market in Europe or United States, partly because China, because of their weather and all that. So, they have made a very unique product for slightly higher end customers, because that's the strategy that they adopted, and they have made a very unique product. They will be amongst the best. They are not Teslas. They are slightly higher end. They are too young, with too little money, but they have actually got much more money than the other ventures do. So Tesla is, the Ather, I would sort of say, is amongst the best product in their class in the world. Unifor started with the totally homegrown stuff, trying to use voice to service our farmers and to people in the rural areas. And they had some success in that, but no major financial success. And as they started getting funding, they started sort of saying, okay, where is the big application? The big application came the call centers. Can I automate the call center? Can I not have to put so many people, and can I improve the performance? Can I do better delivery? And they started with in India. The important thing there was that it has to be done in Indian language. And if you see, all the voice work that others had done was in English. And to some extent, Chinese had done it, Spanish it was done, other language was not done. They, on the other hand, had not only to do Indian but multiple Indian languages. So their strength became that they can handle multiple languages. They had to innovate right from the scratch. And as they started looking at it, they realized that in the world there are about 100 major languages. So that is where they have started getting into. And that's again fairly unique. Uniphone is a very interesting company. It recognized that it has ability to develop technology in multiple languages. And there are a large number of languages, about 100 languages around the world, where work is needed. And they said in English they will not be able to compete with the Googles and all that. But in other languages they will develop the competency. And then they will specifically focus on competency for the call centers, whereas Googles, etc. are doing it in general. Still, I would also say the people like Google, because they get so much of data there, the fact that they have data, they have ability to learn this better. But Uniphone is giving them certainly money. Yeah, and they are not in this domain. So in this domain, they are starting to become more dominant. The next 2-3 years will be very crucial because their dream is to become a company which will hit $10 billion. Not many Indian companies look at something like that. And I think that is going to see them through.
Purely in Indian languages?
No, they are not. They are working in Vietnamese, they are working in Bhasha, they are working in multiple Indian languages, 100 languages. They will be in 100 languages.
Including Chinese?
I don't know. Whether there is a market for that will depend purely on that market.
Okay, now the other thing that comes through in all these interviews, I have a feeling that 90% or 95% of the time you talk about the achievements of the incubation cell rather than research, academia, industry collaboration. I have a feeling that academia industrial collaboration has still not reached anywhere near where you want it to reach.
Yes and no. First of all, when industry and academia collaborate, I do not get to know the details. I mean, I don't have as much stories. I play a role in the initial starting. After that, the work becomes confidential very quickly. For example, Saint-Gobain has number of patents and use that to commercialize product. I can dig out a little bit of details, but not so easy. And we don't even want to start digging out details because it shouldn't threaten the company. We have to stay away. So, number of such examples that I will be able to do will be somewhat limited. Whereas the incubated companies, we see them a complete. So, I will give more examples from there. The only thing that I can sort of say, is there enough work going on? We have a credit system and we see the interaction. Is that going on? We see that is going on. Is that increasing? Yes, that is increasing. Should it go much more, accelerate much more? Yes. And I think years in future will show it.
But a good metric would be the number of patents created in collaboration.
Some extent, some of them don't file patents. Some of the industry will work with academia, do something and just keep it confidential. Then not everything patent is filed. Patent something is filed which, after you release the product, others will be able to somehow figure it out and replicate it. If it takes a long effort to do that, you don't file patent. But in fact, patent is a disclosure. So you don't want to unnecessarily disclose. In many of the work that we do, there are lots of tricks we don't want to disclose.
Even in the incubation cell.
Incubation cell, in our own product development, we don't disclose, we don't file patent. Because if we disclose, People will find a way to do the same thing in slightly different manner. And who is there? What? We don't have time to go around fighting people. So it depends on how long the market is. In pharmaceuticals and all that, the patent stays for a very long time. Many of the other things that we are doing, it is not of the kind that patents play such a major role.
Okay. Before we move on to solar and electric vehicles, I just want to ask you one very important question. This is a fantastic foundation for 10x. Yeah. But doesn't 10x require resources of a phenomenal amount?
I think we can raise it. I am very confident we can raise it. Because the kind of success that we had, I think there is a huge goodwill. There is enough money. So at one time I kind of thought that I may need 500 crore rupees every year. Alright? So it will be tough, but we can raise it. If we really are moving in that direction and are successful, I think even government will support, partly. So I'm not worried about resources at this stage. When it comes to, we will face it, we will figure it out.
But the private sector that would support an endeavor like 10x, is it a donation or do they earn?
So, like for example, we are talking about large number of companies becoming 500 crore or 1,000 crore rupees. We will certainly take some kind of royalties or some kind of a stake in the company. So, we will earn quite a bit. So, soon it will start earning. We will also go to the people who are going to be able to give us some grants and donation. There is enough CSR money in India, and we can tap that for work like this. As you start succeeding more and more, if you really need it, I don't see money is going to be a serious problem. I also believe the government will provide money.
Finally, if one were to describe it in a few words, something like 10x or something like what IIT Madras Research Park does, would it be fair to say it is IIT Madras is like an angel investor plus technical consultant?
Well, I don't think that this is the right terminology because we will make it happen. Neither angel investment makes it happen, nor does the consultant makes it happen. We are going to be driving this. So in that sense, it is very, very different. Though there will be certainly element of angel investment, there will be certainly element of tech consultant, but I think these are what we are, the very goals are highly inspiring. I think lots of people will join us simply because of the goals. I've always believed that, and I probably talked about it, that when you have a large objective, there was this Hindi film dialogue that all the stars align and then, that starts happening on its own. That which one? The Shah Rukh Khan and Deepika's Qayamat. So they align. So that's what makes it happen. I've seen it. Why did wireless in local loop? Why were you so successful? If I look back and try to say, could we have taken such a ambitious work? Many times I feel we couldn't have taken such ambitious work. You can't do it with so little resources, so small a group. And yet, stars align themselves. I strongly believe that kind of thing happens. So
the universe conspires. That is what it is in English.
I think basically what happens is that people get inspired. And when people get inspired, they actually are capable of giving out far more than what they normally are. That's what happens. And I think this is the only way the dreams, large dreams, will make this happen.
Okay. Now let's go on to solar energy. But I want you to talk about solar energy initially for the layman.
So let me
Like, what are the technical obstacles?
So let me talk about something. First, the background.
Yeah.
We are electrical engineers. We were in telecom area. Myself, Bhaskar Ramurthy, Timothy Gonzalez. We had absolutely no understanding of electricity, generation, solar, what to do, etc., etc., etc. I don't remember the exact year, probably 2011 or 12. There was a huge shortage of power around the country, and there was a very, very heavy shortage in Tamil Nadu. To the extent that in Chennai there used to be 4-hour power cuts. Now IIT negotiated with the electricity department and we managed 2-hour power cuts. So we had it between 4 p.m. and 6 p.m. First of all, our work will completely stop. Hot weather, 4 p.m. It was May or something like that. It was just unbearable. And morning after morning, we'll come to our office. Bhaskar's office was just opposite mine. He will come and sit down. I sort of say, why doesn't anyone not do something in the area of electricity and energy, what we did in communications? Communication looked impossible in India, and we made this happen. Why can't something like this be done? And it was a more of a kind of almost complaining and sort of saying there is nobody doing it. Then one day, it happened several times, 2-3 times, and one day I told Bhaskar, there is no point in talking like this. We should do it. And he was getting more and more into administration. I said, I will do it. So, that's the way we started this whole thing. It was probably maybe earlier, 2010 maybe, not 11. Now, I had no idea of what solar is. So, there was one Dr. Kumarvel who was in CEC, Central Electronics Center, associated with our department. That center was more a center which took old equipment, non-functioning equipment and repaired that. And over years had created huge expertise. It was not even a center which used to teach. It was not an academic center in that sense. I knew Dr. Kumarvel there had done a lot of work on solar. So I immediately called him and said, teach us something. So he started telling us something. This is the time we realized that yes, there are solar panels. And solar panels are now available. Their costs are still high but coming down. And maybe if we put that in the sun, we will get electricity and it will give you DC electricity. I didn't even know that it gives you DC electricity. Right? So, immediately the issue came that, okay, so panels are available, it gives you DC electricity. What do? You have to convert this DC electricity into AC. And I said, let me first try to see whether in my home I can put a small unit. So I have a limited amount of money, I'll buy a small panel. So I'll take DC electricity, I'll convert it into AC electricity and then connect it to my fan or connect to a light. So you did not require a big solar panel. A 125 watt solar panel, which is a 1/8 of a unit. 1 kilowatt hour is what you do. So 1/8 of that we could possibly use. And it probably, if it's converted into AC, it will at least light one fan and one light. That's all that we were looking at that time. Can we at least enable something like that in something which is affordable manner? We had understood the affordability issue quite well. And when we started doing calculation with him, we saw that this DC to AC conversion was huge loss. My solar panel was expensive at that time, and then there is a huge loss. So my first focus was, why should there be this loss?
Transmission loss.
No, conversion from DC to AC. And he said, well, nothing can be done. I said, why can't we make it less lossy? And I even inquired around few of my other colleagues who were in different areas, in circuits and all that. He said, basically you are doing small power, because light doesn't consume too much power. 35 watts fan, 70 watts, and you are trying to convert that. There will be a certain minimum loss whether you like it or not. That's where the problem is. So I was quite unhappy about that. It is at that time, while we're still sort of figuring out, do we have anything to contribute in this and what can we do? I suddenly was reading something and I found that at that time LED lighting was just emerging. Till that time it was a tube light CFL. LED lightings were just emerging. And I found that LED lighting was a DC light. Then immediately I said, why do you have to convert? Why can't I directly connect to this? And we quickly experimented and we sort of said, yes, some we have to connect. The sizing will become important, we'll put sizing. And lighting, LED lighting can be done fairly. If you don't convert, because you have to convert that DC to AC, and if you are going to use AC light, you are going to do AC to DC. So two conversions, because the LED was DC. So two conversions are involved. And so we can avoid this conversion. The second thing Kumar simply sort of pointed out to me, that from solar the power will come and you have to utilize all of it. You can't throw it away. Unless you do some storage. So you have to put it into a battery. And battery is also DC. So if you were doing DC to AC conversion, and then we are doing one more AC to DC conversion, to put it into a battery, when we take the power out of the battery, it is again DC. I was again doing DC to AC conversion to put it on the line, and then again I was doing AC to DC conversion. I said, this is foolish. Why? Because all the equipment etc. is on 230 volt AC. I said, what if we make the equipment on DC? We figured out DC 48 volt is something that I can easily do. I can put the power into the battery at 48 volt, take out the power at 48 volt, and make a LED lighting at 48 volt. And suddenly I found that I save about 40% of electricity. So almost halving the cost. That looks very attractive. Meantime, solar panel cost is going on, coming down. Of course, it will mean a totally different standard, and nobody seemed to have that standard, and tube lights also has to be made with that standard. And very soon that I found out, the fan, that ceiling fan that is there in your home, in my home, all of them consume 72 watts. And it uses what is called AC induction motor fan. Then casually, Kumar once told us that if you put DC motor fan, then the power consumption will be very less. I asked him how much less. He could not tell me. But I searched around and I found that a DC motor fan will consume less than 50%. That kind of sort of thinking, that why not have a DC fan? So, and I remember that when I was a child, in our villages, we used to have DC fans. So Kumar knew all about it. He could tell me, yes, there used to be DC fans, but there used to be these carbon brushes which used to wear out. I said, I remember that every year it used to be all taken out, and a huge amount of black dust will come out, and you had to every year replace that. They won't last long. So those kind of things are not suitable. But in the meantime, we found that this brushless DC motor fans are coming. We immediately jumped at it and said that why can't we use something like this? make things slightly expensive. But once again, we are replacing with everything with electronics and some magnets. Magnets cost may not come down. Electronics cost, we're very confident that will come down with time. Now, so we shall say we will make a 48 volt fans. We'll make 48 volt fan. We'll make 48 volt LED lighting. Solar will be DC 48 volt. Battery will be 48 volt DC. Everything will just go as it is.
It leaves just the fridge and the AC.
We'll come to the fridge and the AC. The problem will be incoming 230 volt. Because solar is not the only thing, I will also use the incoming. So I have to convert that to DC. That's the only converter. But I am converting the AC line, which is alright, which is, even if there is a loss, it's a little extra cost. Instead of 5 rupees, I will pay 6 rupees. But rest of it becomes, because the solar was expensive. So we conceived of what is called solar DC. Now, theoretically everything looks fine. How do we get it going? And who will believe it? Well, we created a startup, Intelligent. One of my students had come back from US. He had worked on LED lighting, LEDs, and I just asked him to start working on this. And he created a startup, started producing this light, DC lights in Hyderabad.
What's his name?
Kushant Uppal. There was another company here, TVS, one of the TVS group company. We were interacting with them. They were making fan. They said with some help they can make the DC motor fan. So we got work with them and made the DC motor fan. So and battery was anyway 48 volt. We could do this. Solar panel we made 48 volt and we connected everything. And we saw that we require now half the panel size. Battery also becomes much smaller. Whole thing becomes much lighter. Now we did that. Now how is it going to do? I said the only way we can do it is that in my office, replace the complete thing with DC. So we did this. We also, cell phone, by the way, cell phone charging was also DC. So, from 48 volt I needed to build a 5 volt converter, but that I did, that also we did. But laptop charging was also DC. In my office, that's all that I was using. Lights, fan, cell phone charging, and laptop charging. And in fact, I went one step further because the televisions were becoming LED televisions, which are also DC powered. So I got hold of DC powered television, so one can also turn on a TV, do some display or some whatever you want to do. All this, and I put this. We had a lot of problems, a lot of failing. It was design and number of times it would fail, but so it meant a little bit of patience on my part. But one good advantage is that if anything fails in my office, everybody will rush to fix it. Evenings, nights, it doesn't matter, and it will get. That was what was done. What was most interesting is that many people within the department looked at the whole effort as very, very problematic. Because this DC versus AC debate had taken place long back. Almost 100 years back. And for whatever, it's actually a very interesting debate. But it had all got its period of AC. And immediately some of my younger colleagues, even some of my older colleagues saying that, Ashok, what are you doing? You're taking country backward. I said, what is the backward that you are talking about? I'm not talking about everything being made DC. That's a separate matter. I'm just talking about on the user scenario. My solar is DC, my battery is DC, my lighting is inherently DC. Fan consumed only 30 watts instead of 72 watts. And actually I could even do speed control. Speed control of a regular fan burns energy. So at the lowest speed, instead of 72 watts, I use 62, 63 watts. And here in the fan that we designed, instead of 30 watts, I could use 8 watts at speed 1. I'm consuming so little electricity. My solar is making now tremendous sense. My colleagues were still not convinced. So I remember I used to keep my door open, have this, and my colleagues will walk and they will look at this and they will run. As if some good. I mean, what is this going on? And it took me several days before I could get them to come inside and look at it and explain. And then they would say, it looks exactly like a, is it really DC? Because what we made sure that it looks exactly like a normal light, tube light, normal. This is, by the way, DC. Do you know that it is a DC? Our fans were also DC. Look like regular fan. I had an extra advantage because I had since a DC fan and it was being done in 2004-13 design, I made everything with remote, so I could control everything with remote. They all got it. Then I went to even next step. What is a refrigerator? It is a compressor. How is compressor runs? Through a motor. What motor does it use? AC motor. But will DC motor not be much better? What about air conditioner? After all, is again a motor. So basically, we sort of pointed out that we can go all DC. And by this time, I started doing things. I then went to my home, converted my home into a DC home, all but one room because still there was some fear that something will go wrong. And then we started converting. Bhaskar's office was converted. One after another, my office was converted. And we started doing this. We then started going to other places, particularly places which had no power. So when we talked about it,
just one thing though, does this make sense only if there is your own rooftop solar?
Yes.
Okay.
Yes. Because if its AC line is coming, then anyway AC has to convert it to DC. But frankly speaking, it makes sense. Even if that is so, there is no solar there. Then you are taking from AC line, but you are consuming much less. Your consumption itself will make tremendous sense. But it needed a standard. So the places where we were initially, we went to the government and sort of saying, this is a very good idea. We presented to the minister and everybody opposed it, saying this has been settled. All the engineers in electricity, Ministry of Power and all that stuff, gas. But by that time, Piyush Goyal was the minister and he was a good friend of mine and I kind of had talked to him. He sort of said, but I don't see any fallacy in this argument. So, but people were, the secretaries and their various officers in the Ministry of Power were not ready to even look at this and try to do even larger deployment. Then Piyush came with a very interesting place. What about the places where you are not able to provide electricity today? There are places, there are villages, remote areas. So one of the remote areas we were told that this Rajasthan deserts, which is bordering Pakistan, we are not able to take our lines, very expensive. Says if that's a place they provide, you will have no objection. So in fact, we are given an order that 5,000 homes we go and connect. We needed a little bulk order so that whole thing becomes meaningful. 50, 30, 100 lines we are connecting here and there. We at times had to take things on camel. We went to remote areas. We went to places which I've never seen. An old woman of almost 63, 64, very pale looking and all that. She says, I've never seen light, artificial light. Candle I've seen, torch I have seen. And we went and connected. We connected schools. We connected, and people could now suddenly study in the evening. Regular lights and fans. So you won't be able to distinguish. That was our key. It must not look that it is for poor people. And we went and connected that. The very huge human tribe. We tried to take it to the standards. That's where we saw huge bottleneck. Because standard making were again all these experienced engineers would not understand this argument and say that AC has one, and they will keep on blocking. The only thing they would accept is, in the meantime, there are a few changes that were taking place. This long distance, very long distance transmission lines, people had found over the last 20, 30 years that DC transmission has an advantage. And that they are willing to concede. And we are trying to make it the distribution. Once power reaches your home, once power reaches your office, can we have DC line? At least as an alternative. And maybe a DC AC line. If you don't want a DC, it can be AC line also and DC line, and it can be connected to solar. Huge problem, huge. Even we thought that the faculty members from other IITs would help. But there are people who were like my department colleague, not different. Say, how can you go to DC? And showing that your cost becomes half, your efficiency improves, none of this was touching eyes. Because our mind is so conditioned to follow the West. The question that I was asked, is there anyone else in the world who's doing it? In fact, prompted me. So while I was installing, they said, let me start talking about it outside India. Maybe in the United States. And I did talk in the United States, and there were few people who were trying similar thinking. In fact, somebody was all saying, in 30, 40 years, everything will become DC because it makes much more sense. And that's the time I came across this big debate. Apparently, I don't know that you know that or not. Edison was for DC power. Though he had a limited view at that time, but today things were very different. But there was a forum, IEEE formed a forum, and there were a number of people saying microgrids, off-grid area, microgrids can go into DC. And I started making presentation. Then there was little more acceptance here. But still, people would keep on creating bottleneck. And I would be very surprised that bottleneck came from even professors. And of course, the electricity, our Ministry of Power people, I didn't expect them to understand. They wouldn't even read things. They would not be able to. But we are able to do it at half the power. So the next big success of this. So what was happening in the meantime is that we had come connected here, we had connected a number of homes, we had created a solar home and people in the research park, and people used to come and see that. And they would say, well, it doesn't look like it is DC. And I used to show that in a small solar panel, I'm able to light this whole thing. So we even got some CSR money and say, go and connect some village where there is a poor power goes off, you connect this. And we actually in Tamil Nadu, in Andhra Pradesh, in Karnataka, we did some villages. That's a time an interesting thing came, that Prime Minister's Yojana for trying to power every home came in. When that came in, they were largely carrying grid and doing everything in a conventional manner. But there are remote areas in Assam, across rivers, in forests, in hills, in Manipur, in Meghalaya, and Jammu and Kashmir, particularly in Ladakh region, they're getting stuck. Taking grid wire there would be impossible. Of course, grid wire has huge losses also, that it was not making financial sense. That's the time somebody came to me. In fact, a request came to me from Prime Minister's office and from Ministry of Power, saying, can you go and connect? Very difficult areas. And these are the places where we were given the orders, and we went and connected some 50,000 homes.
Which would mean solar panels and the entire distribution system.
Yeah, it was individual home system, a solar panel, battery, the 3-4 lights, a fan, cell phone charger, and a possibility of a television, though we did not provide the television. So this is something we did in 50, 60,000 homes in Assam, Manipur, Meghalaya, Jammu and Kashmir, and Rajasthan. And the reason why we are able to, these are very difficult terrains. And the Chinese were pushing similar kind of thing but with AC. The problem in that was because there is so much loss, normally cost will go up, sizing will increase. And carrying these across the mountains etc. will become very difficult. Ours were simpler system. In the meantime, instead of lead acid batteries, we were starting to work on lithium ion batteries. And it was a very compact system. And we started carrying that.
When you say we, you mean that company, Intelligicom?
No, Intelligicom was one company. TVS, there was TVS Group company which was making fan. There was a company that we incubated called Signi, which actually made the inverterless 500 system. That was doing. Maybe we should walk and I will show you some of these things and we can film that. Come. So see this solar panel. This small solar panel that you see, can you see the 125 watts? Looks like a toy. By the way, the prices of solar panel collapsed over last 5-6 years. So while this would cost considerable amount, 5,000-6,000 rupees when we started, has come down to 2,000 rupees. So that also is a big advantage. Not 2,000-3,000 rupees now, 23,000 rupees. Come, one will say, what can one do with this? I'll show you what we do. In the meantime, is take you and walk you to some of the electric vehicle batteries and other things. And while we come back and then see various kind of batteries, lithium ion battery. This is 1 kilowatt hour, 1.7 kilowatt hour lithium ion batteries. These are batteries which are being designed for this vehicle, for the two-wheeler. These are all electric two-wheelers that we are designing. We start from cells. Can somebody give me any cells? We have some cells, simple cells.
This has been entirely fabricated here?
Completely fabricated also. So if you see this, no, don't take out anything. No, yeah. That doesn't matter. There are individual cells, a variety of kinds. So you start with that, you get the cells, you figure out how to make batteries. So these are the batteries which are 1.7 kilowatt, 2 kilowatt hour. All these are batteries for two-wheelers, three-wheelers. They are all different cells. You can see the batteries are very different out here. We will show you the other batteries. So you can just film that. See the different colors. This is a larger battery. This is a battery which is for a larger vehicle. This is a small vehicle battery. So all these batteries are completely designed out here. We'll talk more about it as we go on.
So these are prototypes?
No, they are all ready. In fact, I'll show you the outside. They are now being tested. So inside we are done. We'll just put the case and we are ready to drive. I'll show you the vehicles which are being driven. In fact, in this battery, in vehicle, both the motors as well as the batteries are pretty much designed and developed by us. So, can you show us? What can you show us? The batteries you can show us?
Yeah, battery will open.
So, if you see the same battery that you saw, it's not a prototype battery. This is the batteries being swapped. The battery swapping is going on this. And the motors also in this is ours. Where is which one is the motor?
The motor is the going car rickshaw.
Going car rickshaw. So it is actually going around. Yeah, so these vehicles or the vehicle from another company of ours, if you see all these motors, batteries, all of them, the two-wheeler, this in which our battery has been put?
Yes, sir.
Show us the battery. So you see the battery that you saw there, just been put there, and this battery is being put. You see, these are different cells. These are very large cells. What we saw in the other room was a small cell. These are other small cells. This is again a battery made of small cells. So all kind of cells, this cell, that cell, see all of them. We actually went ahead and designed. It's now not fully functional. This is a much larger system. Again, solar and DC. All these lights are DC. There was a DC refrigerator which I have removed. There's a DC mixie. We designed a DC mixie. Afterwards, also a motor, a television, and everything was made DC. So basically, we started doing this. Assam, Manipur, Meghalaya, Jammu and Kashmir made a huge mark. We also started doing it wherever there is a poor electricity. And we also started doing urban homes. In fact, number of homes in IITs are connected like this. We expected that the government will take forward and standardize it and sort of say, well, this is an option for India. But India does not take the lead. India always follows behind, and they kept on asking questions, but has anyone else in the world does it? So it went up to a certain extent where we showed that we can save costs, increase efficiency, can make something which is unique in the world. We can do it in India and take it to the whole world. With very meager support, we were able to go only so far.
I'm horrified. This reminds me of Galileo versus the church. Galileo saying no water. Really? It reminds me of that, like when you're saying the establishment doesn't understand something which is so obvious.
Yeah, this was
demonstrated.
In fact, the system, our whole thing, IEEE in 2017 awarded as the best product of the year. Something which makes the difference in life. I mean, they have two categories. One is a very sophisticated product, another is the one that impacts the life. They awarded that. Even then, you see, with so much support, we got awards, we got this, but it did make a difference to some extent. But I wouldn't say it caught. So today we are looking at a slightly different. We are looking at, well, you provide AC. In the meantime, solar panel costs came down, so that's the advantage. So to some extent, the loss of energy, the amount is probably makes a less of an impact than at that time. The other thing,
still, the point of renewable energy.
Yeah. The other important thing that I think we miss out is that in large homes, if I design a 5 kilowatt solar panel, then it doesn't make as much of difference because DC to AC conversion loss, it has the first 25-30 watts loss, plus after that only 4-5% losses. Whereas in the smaller one, there is first 10-15 plus 15% losses, so you are talking about huge losses. So you are talking about overall 50% losses. Whereas in larger thing, the total loss is about 15 to 20%. So generally it is accepted saying don't disturb the established convention, 15 to 20% is all right.
But the argument is renewable energy, for which AC has no argument.
So the arguments, even when you put solar and you convert it and then use it. So renewable energy is being used, but with 15 to 20% extra losses. So in larger homes, probably it is also okay. In smaller homes, that 15 to 20% becomes 35 to 40%. And that's where this made much more sense. And when the cost was high, it made much more sense. So the cost came down, saying that no, don't disturb the existing.
Let me ask you.
There was however, still some people believe that it's a matter of time before distribution at homes and offices will become this.
Let me ask you, farmers need electricity at all kinds of odd times to work in their farms, right? And they have to wait forever for the electricity department to switch it on at that time, right? For the motors that are used on their farms, highly disaggregated.
So I think the DC makes a lot of sense. Here and there things are being used. Here and there we are able to make an impact. But the kind of dream that we had around 2014, 15, 16, after we installed this and saying that, yes, this is what India will lead, that has gone. That no longer is there. as the solar panel cost keeps on going down, one important thing is that solar is becoming very, very low cost. Today, solar energy, large solar farms feeding to the grid cost in India only, electricity cost is only 2 rupees to 2 rupee 40 paise per kilowatt hour. Wind cost has also come down, 2 rupee 50 paise per kilowatt hour. New plants of coal in fact cost higher, 3 rupee 50 paise. And so in India it makes immense sense for solar to go all the way and wind to go all the way. That's a centralized solar. Why? The question is therefore, why can't we replace all the coal plants tomorrow? Anyway, coal plants are highly polluting. There is a huge issue of carbon emission and the greenhouse effect, and so why can't solar and wind completely replace it? The key issue is solar and wind is not controllable. Whenever God wishes it, sun is there. Whenever God wishes, sun is there. There is a wind. It's not in our control. Our usage is whenever we want to use it. So the solar and wind can become 24/7 only if you put into storage, battery storage. In a small way, we are doing storage in our solar DC system. You saw the 1 kilowatt hour system that we had built. What we require is a much 1,000 times bigger systems, and store the solar energy and wind energy and then use it. That is the direction India is going to go, and this direction world is going to go. But all this was for centralized solar. What we are trying to do was decentralized, which would have made a huge difference in rural areas. I still believe there is a play for this, and it will probably come back. Just it takes time to come back. So that is what is like. Big batteries are very important for grid size storage. In fact, in a building like this, can I become 100% solar and wind? I can bring in solar and wind from outside. I have rooftop solar, part of it, but I can bring solar and wind energy. But solar and wind energy has to be consumed immediately. So I'll require large batteries. In fact, in this building, if I put a 20 megawatt hour battery and store the solar and wind power whenever it is available, and then use it whenever I need it, I pretty much can become 100% solar and wind. And we have plans to do that. For the next 3 to 4 years, we have planned to do that. And we have shown today that doing this with the kind of knowledge that we required for battery, the cost will be lower than the cost of today, where we are getting everything from the grid. This is the direction India needs to go for. Initially, for all these complexes, there are 40,000 such complexes in the country. If we convert all of them to renewable energy, it makes a huge difference. And then, in the meantime, we'll do grid-sized batteries, which are not just 20 megawatt hour, probably 100 megawatt hour or a 500 megawatt hour. And we will soon be able to do that, and it can become a completely solar and wind fossil-free rather than depending on the coal. Coal is a very big problem. The two countries, India and China, are the dominant producer of power from the coal. And there's a huge pressure for us to cut down. Of course, our per capita consumption is still very low. And we are using that as an argument. But it will go only so far. For India, unfortunately, US was not moving as rapidly away from coal and for renewable energy. And therefore, we got a little bit of leeway. But I think their renewed focus on solar and wind will put immense pressure in India. India has no other way but to go for solar and wind with battery technology.
I'm going to say something very laymanish. Yes. Battery technology is so important for the future of India energy. But the lab that I saw seemed to be a tiny little room. So I'm wondering, does it have to be a massive thing given the scale of the problem?
Come. So this
connects research park to IIT. It's our own private bridge. We have a direct connection to IIT Madras, and we don't have to go through the road. Actually, we paid half of it, research park, and IIT Madras paid half of it. And in the middle, we joined. And it kind of symbolizes that academia on the other side, industry on the other side, coming to a bridge. This is what we are trying to do, and the rest of it is all IIT. You can look at the IIT. So you can look at this. The whole thing is IIT. IIT on this side. That is where the research park is. So industry academia bridge symbolizes this a lot. So I'll answer your question while we are walking. Yes, the battery lab. This is not the only battery lab. There is a battery lab in IIT Madras. There is another section of the battery lab, and yet it appears to be a small effort because largely funded, little bit by industry, little bit by government. It is not a heavily funded, mandated program for the government. We generally resist being part of that because it is too much controlled by the government, and when it is too much controlled by the government, big innovations don't take place. The big trying to focus and get industry to win in a big manner does not take place. The vision is still not very clear. There can be policies. CIO can announce that and all that. But finally, if you really want to make a difference, it has to be something independent of the government. And that's what we're trying to do. Let's go back to the office.
But while we're doing solar DC system, we actually attained a fairly good understanding of lithium-ion batteries. And by then we have realized that India has to move in completely solar and wind, and batteries are going to play a very important role. And we also realized that one of the most polluting stuff that is going on is the vehicles. And the electric vehicles are just starting to come. So we naturally sort of combine this solar batteries to electric vehicles. So we started learning more about electric vehicles. 2016, I knew, 15, 16, I knew very little about electric vehicles. We are starting to interact with it. I happened to be on the board of a company called Mahindra Electric, which was actually making electric cars. So I learned quite a bit from there. And we are trying to figure out what can India do and all that. And that's the time I decided, at the request of Piyush Goyal, to spend about a year and a half or so with Piyush Goyal as his principal advisor in Delhi. And when I went there, I was with Ministry of Power, and of course, I couldn't do much work with solar and all that. There was already a lot of vested interest there, and it was difficult to kind of push things in. Piyush told me that, why not take up electric vehicle? It's a very important area. I said, yes, this is my area. I would love to take it. So I started trying to figure out and talk to the industry. I was already in touch with them, and being there in Delhi, in the ministry, it becomes easier to get people to come and talk to you. And when I talk to them, they're all complaining that, yes, we want to all go electric vehicle, we understand the technology, but the cost is too high. And all that you have to do as a part of government is help us get the subsidy. If we get the subsidy, we will make electric vehicle possible. The impression that I was getting from Piyush Goyal and from others, that the subsidy will be very difficult. If at all you will get subsidy, you will get very minimal subsidy. Of course, the industry was going on banging that that's how China is giving large subsidy and how US was giving large subsidy. What was being told that on vehicles getting large subsidy is not, India doesn't have that kind of money. So, Piyush one day challenged me, figure out what you can do with zero subsidy. And this was a very big challenge. So one day, I called all the CXOs of most of the companies which were involved in electric vehicles. There were about 100 people in that meeting. And I started talking to them. First 45 minutes, 1 hour, they all were getting on saying, we need subsidies, and I then told that, well, we can talk about subsidies, but let us first talk something a little more fundamental and kind of figure out what can we do. So people agreed to do that because they had first half an hour, 40 minutes, they had told what they wanted to tell. So we sort of said, let's take a simple thing like an auto, three-wheeler auto. There were many companies who were very interested in converting that to electric. They were doing it. I asked a question that in that auto, electric auto that you people are all designing, claim to all have, what is the, I asked him the question, kitna deti hai? Now, kitna deti is a famous slogan of Maruti in terms of kilometer per liters, or how many liters required for a kilometer. And this had become the buzzword for vehicle purchasing and comparison between this. So I asked them that for auto kitna deti hai? People couldn't understand, surprisingly. In fact, some of them sort of say it doesn't run with petrol. I said, fine, but it uses energy. How much energy does it require per kilometer? So, since it's electricity, how many units of electricity or how many kilowatt hour of electricity is required for a kilometer, or reverse it, per kilowatt hour, per unit of energy, how many kilometers can I travel? I was quite surprised that I didn't get a ready answer. If I ask them this question about their petrol vehicles, answers will come like this, because they are all CXOs. But I saw that as I was asking this question, SMSs were going on. After about 10-15 minutes, people started giving me the answers. I pointed out that it is not there on the top of your head. One of them commented, how does it really matter? After all, we need subsidy. So, okay, let's discuss how much does it consume. So, somebody from TVS Motor said, it is 80 watt hour per kilometer. Others also said 75, 80. I asked why. Why is it consuming so much of energy? Why can't it consume 45 watts hour, 40 watt hour, 50 watt hour per kilometer? The first answer was, well, that's what it consumes. The other answer was, no, it's not possible. The third answer was, why is it relevant? We need subsidy. Then I have to point it out that if you consumed only 40 watt hour per kilometer, then the battery size will go down to half. And battery size is 50% of your cost. Your cost comes down by 25%. And you are asking for 25% subsidy or 30% subsidy. Here is an alternative. People understood that. Took some time, but they say, sir, not possible. I say, why is it not possible? What have you done to figure out that it is not possible? And there was a question going on. Somebody sort of said, sir, we will be able to do 65. We can push it. I say, what is required? I first tell me what is required. So again, this person from TVS got said, sir, we know it very well. If we reduce the weight overall, energy required per kilometer will come down. Fine. If you use better tire, the losses will be less and we will require less energy. If you do better aerodynamics, which they thought they have got whatever they want, but you could improve. And if you do better motor and controller, whose energy efficiency is higher, you will be able to reduce the energy required. I said, well, you have the 4-point program. What can we do? They say, sir, no, but it will push up the cost. Everything will push up the cost. I said, do not worry for a minute. And I actually pointed out that if you can reduce, the battery size will come down. So yes, it will push up some cost. Battery size comes down, your battery is the dominant cost. That will come down quite a bit. So don't give it up. Let's at least discuss. Then they say 65 is the best that we can do. I could see mobile phones coming out, messages going back and forth. 65, 63 somebody said. Till one youngster, startup, said, sir, I got something with 47 watt. That kind of broke the whole thing. And within hour of discussion, we said that we can aim for 45 watt. I had actually done computation from theory with help of somebody, and I knew that theoretically 40 watt hour per kilometer is possible if you have the best possible system. So 45 becomes very reasonable. You cut down your battery by about 30%, 35%. That 35% cost reduction is there. And actually in volumes, the cost is more of R&D in better aerodynamics, reduced weight. It is not really material cost. Yes, the tire will require a little extra cost, but it was marginally extra cost. We asked the same question for buses. A full-size bus was requiring 1600 watt hour per kilometer. We again started discussing and we set up a target of 850 watt hour per kilometer. So that was very, very important day. There was a lot of reluctance that day, but a new R&D started in India, which has not been talked about, not celebrated. Industry was working, some academia was helping, there was occasional collaboration, there was startup working. Today, in 3 years' time, we comfortably do between 45 to 50 watt hour per kilometer for our auto, and we do between 800 to 950 watt hour per kilometer for bus.
In this, in the reduction, if you talk about aerodynamics, if you talk about tire, and if you talk about motor efficiency, what is the contribution of each?
Motor efficiency played the biggest role. Motor efficiency played the biggest role, and that's where the gain took place. People are using induction motor, AC induction motor, which was not the best for something like this. And that's where first brushless DC motor started using, and PMSM motor was permanent magnet synchronous motor. Look, same thing is happening. But what is happening with the fan? You are starting to see, and you are also seeing that AC induction motor had a peak efficiency at one speed. But in India, speed will vary with the kind of traffic that you have. And the brushless DC motor and permanent magnet synchronous motor, you could have a very flat speed curve. So this start was a dominant. The second important thing was tires. Tires, fortunately, they all had. They had tires for better, little more expensive vehicle. All that they had to do is migrate to this. And migrate to this, we saw that the difference was only a few percent. So we got little gain in terms of weight, because weight depends on passenger and all the thing. We haven't done enough, probably not too much. Aerodynamic, because the vehicles are kind of well set, not much could be done. So this was the first thing that people sort of said, well, in the beginning people are saying we need 40% subsidy. After this discussion, They say, sir, 15% दिला दीजिए, हमारा तो काम हो जाएगा. We can do this. So what was interesting is that all the established companies accepted that 45-50 is possible. It requires some work, but they will get there. Eventually, they will get there. And they got there. Over the last 2.5 years, they have got there.
What is the experience in other countries?
I don't have the number, but first of all, these smaller vehicles, three-wheelers are not commonly used. Buses, yes, they have also been moving from an inefficient. Two-wheelers are not there. In China, but from inefficient motors, there is a movement towards better motors. So that part is going on. But are they focused on efficiency? Not as much. You don't talk much. For example, Tesla was using a induction motor, a highly inefficient motor. It's only now they are changing into an efficient motor. They could push up the cost, use larger battery, and get away with it. In India, you couldn't start with that. That's it. We went to the next step and say, fine. Now, how much does an auto travel? 125, 130 kilometers per day average. We found rarely travels longer than that. So it requires this size of battery. We figured out it requires this size. I say, what if we cut down 150 kilometers per us? What if we have smaller battery, which is 50 kilometers? The cost will come down to 1/3. They said yes, but then now the range is only 50 kilometers. And after that you have to charge. And charging of a battery for best life takes several hours, 2-3 hours. Nobody is going to wait. It's at that time we came up with the idea that why can't you swap battery? Go to a place and swap battery instead of charging batteries. And we came with the idea you don't even own the battery. Battery is owned by somebody else. Let's say BPCL decides to put such batteries in every petrol pump. You just go into there and take a battery, give your old battery back. You're tired of with BPCL, so you can return only with that BPCL locations. So you can swap battery. It has multiple. First of all, people talked about it's going to be very difficult. I said, why is it going to be very difficult? He says you have to make the battery swappable. The connectors has to be brought in, brought out. It has to have reliability issue. So I sort of say, are these engineering problems or fundamental problem with technology? There is no fundamental technology problem. It's all engineering problem. I said, but is that not what we are good at? And then we reminded them that how many countries in the world have LPG gas cylinders? Everybody was using pipe. And this was a huge push in 70s and on, that we will put LPG gas cylinder pipe, LPG gas pipe. People pointed out that cost of doing this, maintenance of this, managing, making sure there is no leak, reaching every home is virtually impossible. And India will face huge problem and long delay. And that's the time somebody came up saying, why can't we just have gas cylinders? The question that were raised was precisely this: connector, standardization of connector, the reliability, what if happens if you don't. But those are engineering problems. Today we have got it, and a country where LPG gas cylinder works perfectly, goes to small town and even villages. There are people employed, but then cost of people is not as large. Would work in Europe where cost of people will become very large. But in India it's the perfect solution. It was opposed at that time. Same. Say, why can't we do swapping? Because then, in fact, the vehicle driver who will buy the vehicle does not have to pay the battery at all. They say, well, cost will go below that of a petrol vehicle. Well, you solve the problem. Where is the subsidy required? You give a vehicle without battery, let them hire battery, they tie up with you need enough energy operator. All of you to make sure that the energy operator makes money. And we did a quick calculation and they will make money. To cost of taking the battery per kilometer will be less than petrol cost per kilometer. Where is the problem? In fact, at one meeting we came up with a problem. And there was largely a consensus in the industry. Some people were still not for it. They wanted subsidy, but many others saw said, well, if this on top of it some subsidy comes, whole thing will move very rapidly. I said, now I can go and put this and it will be possible. Now, with this, if we say we are going to scale it up, maybe government will come up with some subsidy.
But the battery itself will be charged from an AC source or from a solar?
Why will it be charged from AC source? Because problem with charging from solar is only when sun is there. What if you have to charge all the time? Let solar energy be fed into the grid and you charge from this. There are many other advantages. This battery is best charged at 25 degrees centigrade. If I was keeping it outside and charging it even 40 degrees and 45 degrees, it impacts the life like anything. Once you take it inside a place, you can cool the battery and charge it. You can charge it slow. You don't need to charge it fast. All this goes away. Your swapping times is only 5 minutes. For the bus, it looked like a large battery, but people said they will come up with a mechanism of swapping batteries. Whole thing made tremendous sense. And we thought that we have got it. It's here, the large industries, which were not present in this meeting, and probably had very little stakes in 3-wheelers and 2-wheelers, and maybe even buses. Companies like Maruti, their companies like Toyota, started opposing this. They're large number of companies. The big companies started opposing this.
What's the reason?
They say, oh, no, it has not been done, this will never work, this is too problematic. And very soon I saw the same music coming from all over the government. Whether it was Niti Aayog or the secretary or they will keep on asking, has it been done anywhere else in the world? Industry was ready. There are of course few people in industry who are not fully ready, and whenever they saw the mood changing on the side of the secretary or minister, they will jump and sort of say, no, they also don't want it.
But how does this adversely affect the auto majors? It has nothing to do with them.
Well, the interesting thing, this would have got India to take off electric vehicles in 2016, 17. This meeting took place in 17 March. By 18, you would have got ready and going. Basically, the big companies were not ready.
Who were invested in fossil engines.
Were not ready. And they basically wanted to slow down. They wanted only confusion to be created. And they started opposing it. Even the European companies, the people who made large chargers, this would not require large chargers, they started opposing. So there is a huge opposition from industry worldwide, which were present in India. And as usual, our government becomes too weak to take a firm stand that something like this can be done.
The very automobile company which in Europe is forced to change to electric vehicles opposes it in India. They follow double standards.
They oppose it in India, they oppose the swapping, battery swapping. They say, no, to go in conventional manner. Let the cost go up, let government come with subsidy. There are people who are looking at importing everything and looking for subsidy. And this program, we fought like anything. Since I was in Delhi, I would go to person after person, convince them. Individually, they will all be convinced. In fact, I went to Maruti chairman, who is a close personal friend of mine. Bhargav. He and I were together on a board of Polaris. And we have even traveled multiple times to United States and to Europe with family. So he used to oppose it. And one day I kind of told him, sir, why don't you spend a little time with me? So he invited me to his home for dinner. He's an old man. 2 hours he went for the whole thing. His comment in the end was, very dirty program, but will work. It's excellent. Keep it up. I have to, however, publicly oppose you. I kept on pleading with him, no. He says, I'll get some of my Japanese people to come and have a talk with you. But we don't think that something like this should be done. See, what is the thing that you see will not work? See, it's just a dirty program of work. It works, economics work. Huh? I gave an example of LPG gas cylinder. Was it a dirty program? So he accepted it. Go try. But so I would face huge opposition. Not to the extent that even Piyush Goyal, who understood it and supported it, did not come out openly in support. And I started facing increasing difficulties. Industry I will take along, will try doing it, and yet there will be opposition. I started creating small companies which would started backing us a lot was companies like Ola and others who saw say they will run this as a service. So there has been for 3 years, from the time I think I came up with this program and formulated and made a presentation to 7 ministers, 8 ministers. The meeting chairman chaired by the ex-finance minister, who is no more, and all the ministers were there. They all felt that it was a very good program. PM could not attend this, but he had deputed a group of ministers to do that. And from that time, where they saw, okay, looks like it can work. And my biggest supporter, in fact, was the person who otherwise was opposing me till then, was the Planning Commission Niti Aayog chairman, who had gone back to US.
Arvind Panagale.
Panagale. He said, well, this doesn't require even subsidy, so this is a self-standing. And his philosophy is that business should stand on its own legs, so he really liked it. But then it got caught again in bureaucracy, and committee will be formed, and this committee, and that committee, and every committee they'll put government people who will only create problems and obstacles. People won't understand, they miscalculate. Kind which was so simple. And it was a biggest battle, I think as big a battle that I faced in wireless phone. In fact, what is most interesting is that May 2017, that committee had the minutes saying that in principle this is the right direction. There was another meeting that cabinet secretary called, where also it says this is the way to go. We should certainly consider it. They kind of blocked it, didn't allow it to go on. Only 2020 September, they have come with a notification that vehicles can be sold without battery and battery can be sold. 3.5 years, but precisely the time the others have to get ready, their costs come down and all that. Only now it is, and in the middle of COVID this has happened. Now, of course, that is going on. But we have lost the 3.5 years, valuable years, by which we would have been the leader in the world. We would have established it. In fact, some people outside the country also started using it. But the kind of opposition that you face, in fact, I was personally attacked. There were lobbies. By now I've become used to it. It was a very difficult period. I remember one day coming to my home and I got some news that they are going to charge me for this or that. And Bhavani was there, Prajot I called, just cried bitterly. I've never cried like that. Because so much you do that everything collapses. In the meantime, the biggest thing that took place, that whatever little support that I had, there was a Piyush Goyal. Piyush Goyal moved from Power Ministry to Railways. Once he moved, the people did against this whole thing. And finally they threw me out of Power Ministry. And overnight, I had to move to Railways with Piyush. I stayed there. Quietly behind the scene, kept on working on it, making Niti Aayog. Any individual that I'll go to, I went, Niti Aayog's chairman is a good friend. I went through the whole thing. I found that there was no real fallacy in our argument. But government, the way it is, we kept on asking, who has done it? Who else has done it? This is the biggest dilemma that continues. Even though today I was very different, I was far more powerful, I was principal advisor to the minister. I was well known. I had Padma Shri, I had pretty much all the awards. I had large amount of industry backing me, particularly small, medium size. Some big ones also. I had support of Mahindra, partial support of Tata's. But I also found that industries themselves play games. They try to figure out where they can get short-term advantage. Anyway, we continue. In the meantime, what I came back about 2018, September, October, and I sort of said this whole thing will happen. But every part of electric vehicle was being made in China and elsewhere and very imported. Battery, motor and controller, charger, and the materials for the battery. And once I came back, I said, well, I'll focus in making us win on that. In a few years' time, we'll make every battery in India. We'll make every motor and controller in India. And we'll make chargers in India. And we'll recycle all the batteries to get materials from batteries. And we'll do it here at IIT Madras. And we'll tie up with industry and provide them. Our motto is very simple. We will be better in quality than the imported Chinese product. But equal to them in prices. Because by now I know that if I don't compete in prices, I will not win. And this is what I have been trying to do for the last 2 years. In the meantime, starting to build the storage battery, while continue to strengthen the research park and go towards 10x, and incubation cell and go towards 10x. This is what I do.
Just one last question before we end. Just like you have a center dedicated for batteries, do you have a center dedicated for motors?
In this is called Center for Battery Engineering and Electric Vehicles. In this, the one work, very strong work is going on in motors. In fact, in this floor, I have a team of 30 people led by this young Kannan who has been driving this, and they are making the best motors in the world. We have a very strong battery team, about 60 people working on battery. We have a smaller team working on chargers, 30 people, 25, 30 people working on chargers. And just now, along with the incubated company, I've started a work on battery recycling. We believe, and there is a plant already operational, that from a used battery, and today we are using cell phone used battery and laptop battery, we are able to recover 90% of lithium, manganese, cobalt, nickel, and graphite. These are the 5 value materials. 90% of these material I am able to recover with zero effluent, no solid effluent, no liquid effluent, and no gaseous effluent. And in such a manner that it's a very, very profitable industry. We had set up a plant, now we are setting up a smaller plant here, pilot plant, automating it, completely quantifying it. And the idea is, can we create 10 such plants around the country which will collect batteries from local sources and create the materials. This is what we are trying to do.
Where is this pilot plant?
Downstairs.
Extraction plant?
Yes, downstairs.
Great. So I am overwhelmed by the entire story you've narrated over 6-7 interviews. It is a magnificent saga of a truly patriotic scientist and technologist. And I really wish you all success. Take India somewhere where we need to be.
Thank you very much. What we have created in the meanwhile is this thing is now becoming a trend. We are seeing many youngsters. Earlier we were the ones who were doing it. Today many youngsters are trying to do it in many, many fields. I just wish one could manage the government. I do not know how to do that. And the bureaucracy. I will tell you a little joke that once Wagul related in one of the meetings. He very nicely used to, when he chaired a meeting every 15 minutes, you will hear something very hilarious. And he told us that once he had a meeting with Dhirubhai Ambani, and he asked Dhirubhai, how are you able to manage this daily so well? We struggle and we are not able to get anything right done. All the time we fail. He said, Dhirubhai Ambani kept quiet for a few minutes, looked at me and said, there is only one SAR. What do you call it? SAR?
Essence.
Essence. One. दिल्ली के बाबू का कुत्ता भी कुत्ता नहीं होता है, कुत्ता जी होता है. We professors are highly incapable of doing this. We are blunt. We tell that you are not right, that you don't fully understand. I've been told by many people. My friend Vijay Raghavan, my classmate, very close friend. He is the Prime Minister's scientific advisor to the Government of India today. He talks to me, and we have talked about this. And I said that why do I face such a strong opposition in Delhi? So he told me that you talk to people and tell them that they are probably not right. They do not understand. That is a no-no language in Delhi. You have to be tactical. Somehow we professors are not used to that.
That's only partly true, because I think you've been opposed by very powerful lobbies on every project.
Yes, it is true. So I think that is the essence of it. So this way of, in fact, I also talk very nicely and sweetly. Now, of course, I cannot, when there is a scientific fact, I can't tell them something which is obvious. I have to point out that it's obviously wrong. I try to do it as politely as possible. But somehow, people are used to that they understand. I'll just end by talking about one interesting thing. My biggest problem was the days when Piyush Goyal had left and the Ministry of Power. And here I had a full program which was ready to go with industry backing everything. And by and large got a little bit of support from the government. And that's a time I saw huge blocking. And I told you that and even attack on me, and so I even cried and all that. So I did not know. For a day or two, I just did not know what to do. And particularly when I was in Delhi, I was all alone, feeling absolutely bitter and feeling very low. And then, so I wouldn't sleep properly the night. One early morning, when I was up at 5 a.m., was doing my exercise, came back, the same moment that happened in wireless in local loop when we heard on 2nd October, Mahatma Gandhi's birthday, the spectrum is not even available. Same moment. In the morning I saw said, well, I cannot just be defeated. What can I do in a situation like this? The only thing that I can do in this situation is write. That later in that day, I started a blog. And for next 10 days, just wrote the blog. The blog was titled Electric Vehicles. The blog title is EV Elephant in India. Electric Vehicle Elephant in India. I start by telling this story about the 7 blind men and the elephant. Because I understood what the problem was. The 7 blind men and the elephant were the 7 blind men who were trying to understand elephant. Each went and touched part of it and got a part of it, never understood the whole. And they were describing it. I remember it as a child laughing at it. And that day I was sort of saying that even the laughing was bad. I mean, they were blind. They could only see that much. But that is the day I realized the essence of that. Then I saw that 7 departments in the government of India, each were experts in electric vehicles. Each had gone and heard about it, read something somewhere. Each had gone and visited some country, saw something. They never visited Indian labs. And had formed an image of what the electric vehicle is. And for them, that is what the electric vehicle elephant were. There are 7 blind departments who are trying to drive the policy. And everybody was right, and everybody was wrong. So that blog, and I wrote in a very simple style. I wrote that about 12, 13 articles. Took me 10, 15 days, did all the calculations, presented all this. And gradually, here and there, people started reading it. One day, about 2.5 months later, while I was sitting in my office in Railway Ministry, by that time I had moved, I get a call that Subhash Chandra, the ZTV head, and an MP have come to see. What has he come? He came, sat down, started chatting with him. But he's very interested in electric vehicles. And I soon found out that somebody associated with him had gone through this blog and understood and told the essence to him. And he says, well, what you are trying to do is doable. And I am not in this area, but I am going to ready to invest with you and work with you and make this dream possible. And he started working with him. In fact, we even took in Chandigarh, the first swapping, and since he was MP and he was very well connected, he was able to even get things somewhat done. In Chandigarh we started. Very unfortunate that that's the time ZTB ran into trouble. For a totally different reason. They were being raided by Geo and they couldn't survive. And ultimately, after 6 months of working with us, one day he came, visited here. He was thrilled. He wanted to do so much on every aspect of our dreams. But one day, he was trying to set up even cell manufacturing. And on his behalf, along with a few of us, we went around the world trying to identify where all we can get the technology for the cell manufacturing. We are trying to close it on the recycling. We are talking about battery making, vehicle operation. But unfortunately, his business got into trouble. And then I got a call saying that over the next 3 months we'll put out. Meanwhile, of course, multiple other people have come and we are going on. But the kind of push that I got because of Subhash Chandra, he came spend time out here. And he was thrilled. He took me, in his personal plane, he flew. We went to Dehradun where this battery recycling plant was there. He became one of my closest friends. This same blog did inspire a lot of people. We still get a lot of very immense interest. And we have not given up. We don't give up. We fight till India wins. Whether the companies associated with us, how much they win, not win, I can't say. But India will win, that I'm confident. The things are moving in a certain direction. I know a number of people in the government, but individually I can convince each one of them, the ministers, Javadekar, Piyush Goyal, this fellow, Yashpal Sharma's son, not Yashpal, ex-finance minister, he is now in opposition.
Yashwant Sinha.
Yashwant Sinha's son.
Jayant Sinha.
Jayant Sinha. Very close friend. In fact, I have more friends here than in any other government. I had Taru Vijay is a very close friend. There are others who I know and talk to them, but unfortunately, decision making is very centralized. This is the dilemma, this is the problem. So therefore, things will happen, but it happens in its own way. I remember making a presentation to Gadkari about this whole swapping, and he somehow, I don't know why something went wrong and he was quite angry with me, and he told Piyush, kahan se le aaye kuch, isko samne nahi aata hai. And today he is the one who has made this, gone one step forward and made the swapping possible. So, overall system still will oppose. I think few more breakthroughs have to happen. We are getting there. That is the lesson. All these lessons were the reason when I built the research park, I ensured that there is no dependence and interference from the government of India. Our incubation cell was built with that. But I'm very worried the day there is an influence of, there is interventions. They will all come for good reasons, for supporting it, but their way of doing things. Very worried about even IIT having too much say on it. Because on the IIT they can put pressure. And IIT also has a certain possibility that individual aims can drift this apart. Anyway, I know we will.
And on that note, India will win and IIT Madras Research Park will play a great role in that. On that note, let's end.
Yes.